Here's here's a really interesting and important application of probability. So the FA, I don't really know who that is, but whoever they are, report the chance of an air traffic controller chosen at random being under the influence of drugs is about 0.7%. Okay, it's less than 1%. So this drug test that they administer is not perfect. It turns out if someone is actually on drugs, then the chance that the test actually detects this is 96%. If someone is not using drugs, then the chance that the test detects this is 93%. Okay? So here's the question, or here's one of the questions we might want to answer. For a randomly chosen air traffic controller, what is the chance that the test is positive? Okay. First of all, let's write down what we know. The probability that someone is on drugs is 0.7%. Okay. I can write it like this. Okay. Also, the probability that, given that they're actually using drugs, what's the chance that the test is positive? Is it okay to write it like that? Probability of the test being positive given they're on drugs, okay? So I'm just going to use this for my positive sign. I hope that's okay. Okay? It's just a symbol. So this is 96%, right? And also, we're given that the chance that the test is negative given that they're not a drug user is 93%. See how I did that? The complement of using drugs is, not being a drug user. So given that they're not a drug user, what's the chance that it's negative? 93%. Okay? So now, what I want to do is get an expression for the chance that a randomly chosen person tests positive for drugs. So, so take a look at this. Maybe here are all the people using drugs, okay? It's actually, it ought to be a lot smaller than that, right? Because according to this, it's 0.7%. But I'm going to make it this big anyway because it's otherwise it's just too hard to see, okay? And I'm going to draw a line straight through there. On the left side of that line are all the people who would test positive for this drug test, And then on the right side are all the people that would test negatively for drugs. Okay, so what I want is the chance that a person chosen at random tests positive. Now, I propose that I can write that as the chance that they test positive and don't use drugs, plus the chance that they test positive and do use drugs. You know what? I know I can do that. Here's why. The chance that they use positive, the chance that the test is positive and they don't use drugs, that's just all of this, isn't it? And then the chance that they test positive and do use drugs, that's this area in here. These are disjoint regions, and together their union makes the entire region called testing positive, right? So yeah, I can just add these two terms. This is this region in here, and this term is this region right there. Okay? Now, here's the trick that I'm going to use. I'm going to remember that conditional probability says that the chance of A given B is the chance of A and B divided by the chance of B. Okay? Now, so I can rearrange that to write that that the chance of A and B can be written as the chance of A given B times the chance of B. Okay? So if you have a conditional probability, if you multiply it by the chance of the information part, okay, then you get the chance of the intersection of the two events. So I'm going to use that twice over here. And this just comes out to be, I can write this then as the chance of the test being positive given they're given that they're not a drug user times the chance that they're not a drug user, plus the chance that they are that the test shows positive given they are a drug user times the chance of being a drug user. Okay, and then finally, so now at this point I can just sub in my numbers. I know all these things. This is 0.96. The chance that they're not a drug user is, by the rule for complements, it's 1 minus 0.007, right? This is 1 minus that. Plus, this number is, oops, wait a minute, I think I made a mistake. Shoot. Let me start this over. The chance the test shows positive given they're not a drug user. Oh, okay. Oops, yeah. Okay, given that they're not a drug user, the chance that it's negative is 93%. So given that they're not a drug user, the chance it's positive is 1 minus that. Sorry, 1 minus 93%. Okay, see how I did that? Of all the non-drug users, the chance that it's negative is 93%. You would hope that it's high, right? But so the chance that it's positive for a non-drug user is 1 minus that. So that's the rule for complements. And then I'm going to apply the rule for complements again to get this. I actually did this part right. I can't believe it. Okay. Now, this part, the chance that it's positive given that they're a drug user is 0.96, and the chance of a person being a drug user is 0.007. Whew, my goodness. All right, so let's do all this with our calculator here. Get 1 minus 0.93 times 1 minus 0.007 plus 0.96 times 0.007. I get 0.07623, or 7.623%. Okay, so that says that the chance that a person chosen at random tests positive is about 7.5%. Okay, so in general, this is called the law of total probability. Law of total probability. Okay, what it says is that the chance of some event A can be written as the chance of the event A given some event E1 times the chance of E1 plus the chance of A given some other event E2 times the chance of E2 plus ... plus, keep on going, the chance of A given E sub n, if you have n disjoint events, okay, that make up the entire space. It can be written like this. Okay, this is a very useful law. Okay, see, maybe you want to know the chance that you win the lottery given the grade that you get in a class. You could get an A.